here's our next one. The ideal gas law is not that there are any changes occurring. So you don't have a P1 and a P2. And this is how you're going to realize which equation to use. If you only have one pressure, one volume, one temperature, and nothing is changing, you're going to be using the ideal gas law. And this relationship was found between any gas. If you take the pressure times the volume and divide it by the moles and the temperature, every single time they kept getting that value of 0.0821. Every single time. You also see me write as 0.0206. That's the longer value. I just sometimes go back and forth. It doesn't matter what the gas is. Pressure times volume divided by moles and temperature gives us that value. What do we call a number that is always the same? A constant. And that's the constant or gas law constant. So R is always going to be 0.08, 206, or 21 liters, atmospheres, moles, Kelvin. And those units are because it's liters and atmospheres on top, moles and kelvins on the bottom when you rearrange the equation. And here's the equation. PV equals nRT. You're basically just going to be, pulling the variables out of the equations, making sure they match the units for R. R is liters. Is the volume we're given in liters? 8.56 liters. So we don't have to do anything to the volume because it's the right units. The temperature was given as Celsius, but R is in kelvins. What do I need to do to the temperature? Add 273, convert it to Kelvin, and then I've got the temperature I'm allowed to use. The pressure is in atmospheres, and so is R. So we don't have to do anything there. R is R. And then moles is what we don't know. So when we get our answer, the atmospheres will cancel the atmospheres out. The liters will cancel the liters out. The Kelvin will cancel the Kelvin out. What's not canceling? Moles, which is the unit we want to have left over when we solve the problem. So we plug this in, all this information into PV equals nRT. We have 1.5 times 8.56 equal to N times 0.0821 times 273. People commonly ask me, why is N the value for moles? Right? It doesn't make sense. I mean, it's moles. You would think that the variable would be M. But we actually just said, Elisa, what does M represent for variables usually? Mass. So M was taken. And actually, capital M is also taken for something we're going to learn later called molarity. That's also already taken. So both the lowercase and the capital version of M were taken. So they went to the next best thing. The letter N comes right after M. So now we need to solve for moles. And I want you guys to solve for moles here. I'm going to give you a minute to try to solve this one. Good. Right. The moles should be 0.57 moles. And what is the gas? Hydrogen, H2. Matt, I might do something evil in this chapter with a question just like this. I might give you grams, not moles. What would you do? You would do dimensional analysis. Exactly, right. Where would you get the value, though, to convert it from mass into moles? From the periodic table. So if I gave you 12 grams of nitrogen in 2, you'd have to set up a little train track dimensional analysis thing, go to the periodic table and look up nitrogen and convert it into moles, and then you have the value for N. So occasionally you're going to have to do some work for N.